నమో నమః అందరికీ నమస్కారములు. గురుభ్యో నమః. Today is the fourth day of our classes on Vedic mathematics by Dr. Goutham Mukherjee ji. Let us start the program with paying respects to our country by singing Vande Mataram. Let us request Salla Chittibabu garu to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malaya Jasitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajyosna pulakitayaaminim pullakusumita drumadala shobhinim suhasinim sumadhura bhashinim sukhadam varadam mataram vande mataram. Vande Mataram.
వందే మాతరం. ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Let us request Bhaskar Rao garu to chant Prarthana, please.
Sir, 1 minute meditation followed by 3 times Om. गणपतिकं हवामहे कविं कवीनामुपमश्रवस्तमं ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पदान शृण्वन्नोतिभिः सेदसादनम्. ॐ श्री महागणाधिपतये नमः. ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती धीनामवित्र्यवतु. ॐ श्री महासरस्वत्यै नमः. गुरुरेव गतिः गुरुमेव भजे गुरुर्नैव सहास्मि नमो गुरवे न गुरोः परमं शिशुरस्मि गुरो मतिरस्ति गुरौ मम पाहि गुरो. ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवम् उपास्महे. श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पादशङ्करं लोकशङ्करं. शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः. ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः. असतो मा सद्गमय तमसो मा ज्योतिर्गमय Orma Amrutangam Om Shanti 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 Matrudevo Bhava Pitrudevo Bhava Acharya Devo Bhava Atiti Devo Bhava Om Sahana Vavatu Sahano Bhunaktu Sahaviryam Karvavahai Tejasvinavadhitamastu Ma Vidvishavahai Om Shanti Shanti Shanti.
ధన్యవాదములండి
ధన్యవాదాలు.
భాస్కర్ రావు గారు.
నమస్తే.
Thank you so much. Now let us request our Guruji Goutham Mukherjee ji to start the webinar, please.
धन्यवाद कर्नल साहब. सर्वेभ्यो नमो नमः. Start the presentation. This we all covered. This part was covered, and then we were here. We did calculation, this fraction of the kind where the denominator ends in 9. Then for other things, 1, 3, and 7, we respectively will multiply by 9, 3, and 7, and then we'll get a denominator ends in 9, and then we'll get the same formula. You can calculate on any of the fractions. We did so many properties of the 1 by 19 that we found that if we just subdivided this part into two parts, we find that if we would have written this thing below this, we'll find that the quotients or the main figures of the recurring decimal, they add up to 9, and the remainder add up to 1. This is 1, 19 to 1 and 9. So their quotients add up to 9, and remainders add up to 1. So now we come to 1 by 29. This I gave to as a home task. I hope some of you might have done it already.
Yeah, sir. The way yesterday we did, 1 will multiply by 2 if it is 1 by 19. If it is 29, we'll go with 3. 1 by 1 multiply by 3, 3 multiply by 3 again.
Divided,
Yeah.
not multiplied. 1 divided by 3.
Yeah.
So you got all these figures like this?
Yeah,
started,
sir.
Started with started with
lower
1
one,
or some other number you started with?
Yeah, sir. 1, then multiply by 3, you will get 3 with no carry. Then 3 will say 9, you'll have no carry. Then 3 will 3 into 9 again 27. You
No.
remain 7. Yeah.
What
I'm talking the one which
actually you did from opposite side. That's okay. Sorry.
Yeah.
Yes, multiply by 3. Yes.
Because that's the easy one.
Easy one. Yes.
Because our mind, without taking the book, our mind will do that calculation. That's why they were taking the opposite.
You don't have to divide. Yeah. Many people, there was a paper on this because people found it is much easier, and there are papers on written from this side to this side. It's okay. You multiplied by 3, and then you kept on looking like that, and you got all these answers. Now, once this particular sequence is there, then you can do. You can find any of the. There are so many fractions. 1 by 29 to 28 by 29. There are 28 numbers of such fractions. Thus, all these things can be calculated. Suppose I want you to know what is that 21 by 29. You tell me what to start. 21 by 29.
21 by 29, that means I need to come 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17, 18, 19, 20, 21. Like 5. If you see 5 from the right hand side and from the left hand side, again I need to calculate 21st position. Is it correct?
No, here the fraction will start here actually. This one.
Okay.
For 20,
Yeah,
because
from
this is 20, this is 21.
Just have
Okay.
to find
Okay.
21. Yeah.
So 21 by 29 will be, you can check with the calculator, by will be 0.724137931 and then comes back to 0344 and ends up at this one. Actually, which that is. And on the other hand, suppose 21 you want to do that, again you have to press the calculator you want to do, then you have to do 1 into 3 plus 2, 5. 5 into 3 is 15. 15, 5 is here, 1 is here. 5 into 3 plus 1 is 16, that way. But
Sir,
once the sequence is there, you don't have to calculate, recalculate again. You simply put the decimal point at right place. Suppose I want 25. I want 25 by 29. Okay.
so
So
then I'll have 2, 5 and carry 2.
no. We have to start with this 8.8620. It
So
will be after that.
what is the logic, sir? Like I was thinking to count, like if you have 129, na, then I'll have first one. I was thinking in that way, like. So is there any shortcut way?
Not that. Actually, you have to because see, if you start with that, it will be suppose I want, suppose this one. So as I told, 25 by 29. So what is that? So had we started with 25 by 29, I would have this 25. I would have divided by 3. So it is 8 is my quotient and 1 is remainder. Here actually going opposite side will not give you the starting point. For want to know the starting point, you have to do that division method. Okay.
Okay.
So therefore it is coming after this one digit after. So if 25 is here, 25 by 29 will be 0.86210, 862.068 and so on. Suppose I want to 15 by 29 I do. So it will be point this one. The starting point will be here, 0.517241. Did you get it?
Yeah,
So
yeah.
this particular sequence gives you all the all the decimal points from 1 by 29 to 28 by 29. By only 28, or even if you want, you know that it is can be folded like this. It is only 14 calculation will make it. Of course, you have to subtract this. The subtraction also will be there. So actually, it is 28 calculations. Instead of had we done by conventional method, there would have been how much total operations? 28 times 28. 28 square. So 28 square thing is only squeezed to 28 operations by doing this Vedic online method or binomial online method. Okay.
So one doubt, like if I have 26 by 29, how do I know I need to divide 26 by 3, right? So 3 8 are 24, 2 will be remainder. So I need to see 8 and a 2 carry, correct? Correct, na? In that way we need
Yes,
to.
actually, yes, it is. So it will be 26 by 28 will be 0.89.
8, 9, 6, 5, 5, 1, 7, 2, 4, 1, 3, 5. Okay.
Comes back to 0 and so on. It will be also same length 28. Okay, so this point is clear.
Yes.
Now, anything n by 29, I already discussed it already. So it is written verbally on the text like this, that you can start from anywhere, and you can just read it. 15 by 29 is this one. I didn't put the remainders here. Having a total remainder sequence, it will be very transparent. If you remove
So
the
this logic, yes, sir. Sorry, this logic will be applicable to, like if I have 1 by 39 or 1 by 49.
It will be, this particular logic is applicable for full cycle. Otherwise, the all will not be there. And if you remove the remainders, you cannot make it whether this 4 is it can be 4, it can be 14, or it can be 24. But if you have all these remainders information, then you know that this is 14 and this is 24, and 4 will be somewhere. 4 is here. Okay. there are difference between these 4. But here you do not get these 2, 4 and 1, these 4. You do not get what is what. So that is the idea of keeping the remainder. Now I come to anything n by a9. So here I have shown that it is 1 by 59. I did it 6, this because 59 plus 1 or Ekajikanu Purven of 59, it is 9, 5 plus 1 is 6. So this is the thing. Actually, you said 58 digits. So 58 digits, and then you can get the similar way. Actually, in Excel sheet, there is a particular calculation. Here it will be integer division following the int, and here it will be this mod function. Those of you know Excel can do it, try it. If you do not get, I will do it. And then you just feed the formula once, and you just copy the formula, drag rightwards. You will get all the sequence, whatever it be the length. Suppose there is a 108, 1 by 109, or something by 109 has 108 digits. You can just feed the formula and can drag, or it will produce all the 108 digits. So this is for this one. So
Sir, if you want to do 1 by 118, so the way 119, 1 by 119, so in that way we will be having 12, right? 1 multiplied by 12, 12 again 12 will be multiplied by 12, 144, 4 again 14 will be carried. That way can we do? I'm talking in the reverse way from the right hand side.
yes, that's possible.
Okay.
You can try. Now, what is the algebraic proof of this basic one-line method? That I kept on telling, that is a binomial. So this is the thing. Those of you who are expert with some this kind of series are, but others also people you can understand that you by binomial you mean that we have learned only a plus b whole square, isn't it? A square or cube or something like that. Only small things. Sometimes everybody has learned this, but everybody might not have remembered this to the power minus 1. So b square, and so this is actually sequence is 1, 2, 1. So similarly for cube, this will be 1, 3, 3, 1. 3ab square, 3a square b, and a cube plus 3ab square plus 3a square, 3a square b plus 3ab square plus b cube. So this is the binomial expression for square, cube, and so on. Here, if we put it minus 1, it will be an infinite sequence like this. 1 minus x to the power minus 1 is 1 plus x, x square, x cube, x to the power, provided the condition is x should be less than 1. Here it can be anything, but here it should be less than 1. Now, this actually also can be written like this: 1 plus x, always 1 plus 1 plus x, like this. But now, 1 by 1929 is a by anything 9, ending in 9 can be expressed as a 1 by 10 into n minus 1. Say 10 into 2 minus 1 means 20 minus 1 is 9, 1 by 9. So if we express it like that, some algebra is there, and then we finally get it like this. And it is actually, it is since 1 by 10, you say 1 by 20, 1 by 30, etc. This means is less than 1. So therefore you can apply it. So now if we clearly, this is like expressed like this. So say 1 by, I tell you, this is actually nothing like that, 1 by 19. So suppose n is equal to 2 if we do. N is equal to 2. If we do n is equal to 3, it will be 29. Suppose I start with this one, 19. 1 by 19 will be expressed as 1 by 20 into like this. So finally it becomes like that. 1 by 20, this is 1 by 20, 1 plus 1 by 20, 1 plus 1 by 20, 1 plus 1 by 20. You consider this all as repeats, these are 20. Okay. Now think in these terms, you will get it very clearly. So 1 by 19, I am calculating in terms of 1 by 20. So therefore, that is the reason why I am actually, when I am dividing by 2, actually I am dividing by 20. That is very important to see. Note. And with 20, because I am putting that result on the next decimal point. So division by 10 is done automatically by our placement in the next position. And this point on a term by term, I am evaluating. Okay, like this, when I am doing the remainder, quotient and remainder, quotient I am putting here, that is like in the place of 1. But the remainder, again, I am dividing by 2. So that way it is going like this. Whatever remainder, this other part, one part is here. So in each of these steps, one part I'm putting on the line, and other part is this one, remaining part, and that I'm dividing by 20 again. Actually 2 and putting it on the result I'm putting on the next line. So this all the explanation of that particular procedure can be done, can be understood by this particular expression. Anyway, that is therefore I named it binomial also. Now,
So this will not be, sorry sir, this will not be applicable to n equal to 1 because 1 by 10 into 1 minus 1 by 9. So for the 1 by 9, it will not be applicable, right?
Now 1 by 9 also can be done, but it will be always, you try this, you take it as homework. You will always get
I'm
the same
trying that
result
only.
because
Yeah, I was trying that only.
anything by 9 repeats actually. It is all, say 5 by 9 is 0.5555 and so on. You'll get the same, you'll get back that same thing. So it is not much interesting, I mean, but it is, you can try it. You can always try, and then it will be already there. Now anything m by something by, suppose say 15 by 19. So m is 15. So it's only they have to do only outside, otherwise all are same. Only starting point is only same, no different. Now I come to this one. Other denominators. For denominators ending in 1, 3, and 7, we have to multiply both denominator by 9, 3, and 7. Okay, respectively. Like 1 by 7 becomes 7 by 49. So we have to start dividing 7 by 5. So 7 divided by 5. So 1 is my quotient and 2 is remainder. And then 21. So it becomes 4 quotient, or dividing by 5 again. 21 divided by 5. 4 quotient, 1 remainder. That way you get all these things. And then we find that this contains, in the same way, this contains all the answers from how many fractions for 1 by 7 by denominator 7, 1 by 7 to 6 by 7. There are 6 such things, and its length is also 6, so it is a full cycle. So therefore, all the answers are here itself. Suppose I want 5 by answer of 5 by 7. What will be? Can anybody tell? 5 by 7 will be 5 by 7 will be 35 by 40.
Yeah, it will be
30, yes.
5 by 7 will be, we'll multiply by, you said, 937 we need to multiply.
So 35 by 49, so therefore you have to start here. 0.71428.
71428. Yeah.
8 by 85. Or 6 digits. Similarly, for 6 by 7, this is the 42 is the 6 by 7. 42 by 49. So it will be 6 by 7 will be 0.857142. Okay, that is the same thing. Similarly, I have shown for these also, you can revise from your homework if you do not get it fully. 3 by 4. 1 by 39. 1 by 13 will be 3 by 39. So 3 you have to divide by 4. So 3 divided by 4 is 0 quotient and 3 remainder, 30, then 7 quotient, 2 remainder. That way it goes, and then you can get. Now here, actually, this is you have to understand. Here 1 by 13 has 6 digits. So it doesn't have a 12. So there will be 2 cycles of 6 length each. 6 length. In case of 13. It is not one full cycle of 12 length, but it is 2 cycles of 6 length. So one is I get from, what are the things you get here? See, 30 means basically I multiplied by 3 both the time. So 30 actually is basically 10. So I get 10 here. 27, I get 9. 36, I get 12. I get 3. 9 divided. I get here 4 and 1. So 1, 3, 4, 9, 10, 12. The other set, namely 2, what are the remaining? 2, 5, 2, 5, 6, 7, 8, 9, 10 is there, 11. This set actually comes from the other side. You please take your homework. You try to find, say, you try calculating 5 by 30. You will get the other set, 5 by 30. So you will not see the digits here. For these many 10 by 13, 9 by 13, 12 by 13, you get all these digits rotation. Say 12 by 13 will be 0.923076. But 2 by 13 cannot be got from here. It has to be separately calculated. 2 by 13, 5 by 13 will be another set. There are 2 cycles of 6 length each. So I hope it is clear. So far we have seen 1 by 19, 2 by 9, 1 by 29, something, or 1 by something by 7. We got full cycle, but here we got half cycle.
Sir, 1 by 11?
1 by 11 only 2 digits. 1 by 11.
Like the way we followed, like the way we use 1 by 29 and 1 by 19, same procedure we can apply here.
Yeah, should I do it?
Okay, for 1 by 11, I'll try and let you know.
By
Yeah.
11. You tell me what should be done. First, what will be the step?
Like 1 means it's 2. Like 1 by 19 we have 9, right? So we have used a 2. So 1 by like I'm coming from the left side because I like that coming from the right hand side instead of going from the left side.
No, not at all. First concept you didn't get.
Okay.
You have to go 9 by 99.
9 by 99.
Okay. Like you said, if it is ending with 1, 3, 7, you can multiply by other 3, 5, 7.
9, 3 and 7 respectively. But ultimately, to aim is to make it end in 9. Isn't it?
Okay. Then you go the old procedure. Okay,
So
fine.
you have
Then
to
you
do
can
9 divided by 10. Now you have to do, isn't it? This is 9 plus 1 is 10. So you tell me how much? If I do 9 divided by 10,
0.9.
what is equal to? What is the
0.9.
quotient and remainder? No, 9 divided by 10 I'm doing. So 0 is my quotient.
0.9, no, sir.
9.
9,
Remainder
9
9.
if I divide by 10, what is the
Remain-
quotient and remainder? 0 is my quotient
0 is your
9.
reminder, yes.
and 9 is remainder. No,
90.
90.
90.
90 I am dividing by
10.
10. Becomes 9.
9.
Goes back to 9. That means it has only length 2 like this. It will be 0.0909. If you do, because it came back to 9 again, so means that again you have to do 9 divided by 10, again you will get 0 again. So it is actually 0.090. Anything by, suppose you do 3 by 11. Okay. So it will be 27
by 99.
By 99.
27. Try 27 by 99. So 27 divided by 10. So how much it is?
2.7. Reminder is 0.
2 and 7.
2.7.
2 here,
2.7.
2
And 7
and
and
here, and then 7 as a
7.
remainder. 72. 72 will be 7 and remainder is 2. Again came to 27. So it will be like this. So that is the idea, that is, since it is 99, obviously it will be You don't have to see, because I told what I told earlier, that as many nines as the number of decimal points. So something divided by anything divided by nines only. Anything divided by, suppose I get a anything random number. Randomly I put anything 3, 4, 5, 9, 8, and so on. I want to divide by 9, 9, 9, 9, 9. What is the result? Oh, sorry, that's 5. There are 5 digits and 5 numbers of 9 I am dividing. What will be the result? Result will be just point and dot here and dot here. Don't have to do anything. So therefore, I omitted that dividing by 9 and so on. That is the idea. Okay, clear?
Yes, right.
Now, I was here. So please take at homework 5 by 13. So you get the other set. Okay, I told that. Next, right. Now, something by 1, ending in 1. I told that it can be numerator and denominator can be divided by 9. I told. So for denominators ending in 1, for fractions like 1 by 21, 1 by 31, 1 by 41, 1 by 11, I didn't do, because you know it is automatic. I told you, so this is not a problem. So therefore, it started with 21. 1 by 21, 31, 41, etc. We have to multiply both n and d by 9. Now see what happens. Thus, 1 by 21 becomes 9 by 189. Such a big number, because I'm multiplying by 9 both the sides. So therefore, digit divisor becomes 19, or 18 plus 1 is 19. Similarly, 1 by 31 will become 9 by 279, and 27 plus 1 is 28. So digit divisor is 20 by 8. For 1 by 41, it becomes, for 36,
9 by 369. 9 by 369.
9 by 369, and becomes 37 digit divisor. 37 plus 1. Therefore, what I wanted to avoid dividing by 21. I ended up in multiply or division by, multiply would do from right to left, multiply division by 19, 28, 37. These are big, very big numbers. Now, so therefore, the basic one-line method will need a change. This basic one-line method will need a change. Now, in that book, there is a, in this particular book, actually, some auxiliary, book can be. So this auxiliary method is some auxiliary fraction or something like that, the chapter is there on. But I found that if we consider the 1 by 21, 1 by 31, 41, etc. in the form 1 by 10n plus 1. So n is equal to, if we put n is equal to 2, so it becomes 21. If we put n is equal to 3, it becomes 31, and so on. So this, we have the binomial expansion of 1 plus x to the power minus 1. Earlier we had 1 minus x to the power minus 1. Now it will become 1 plus x to the power minus 1. 1 minus x plus x square plus, the alternate. Earlier everything was plus, if you have noticed. Earlier with 1 minus x to the power minus 1, it was 1 plus x to the power x square plus x cube plus x to the power 4, and so on. Here it is alternately signed. 1 is minus, 1 is plus, 1 is minus, plus. Therefore, this one, this which is little algebra, we find that it can be again done like this. And I elaborate it like this here. So binomial expansion of 1 by 10n plus 1. Suppose it is, so you consider 1 by 21. So I can express again in terms of 1 by 20, 1 by 20, but alternate sign. Alternate sign. Earlier we did everything minus. So we have to always do. Earlier, suppose I had a quotient, say 5 and remainder 2. Okay. So the next division was how much is it? I consider is to 25, isn't it? Means that 2 into 10 plus 5, 2 into 10 plus 5. Here you have to do 10, 2 into 10 minus 5. As if we have considered that this particular is on a vinculum. So that is the idea. So to practice that, so initially if we start with 1 by 21, you'll get a lot of things like negative and so on. So for practice purpose, it is not very good. So I skip that and I will come back to this later. Slightly later, on a today itself, on a slightly later. I start with my favorite one. Take say 14 by 41. 14 by 40. You could have done also 6 by 41. Could have done 19 by also 19 by 41 also. This whatever is bracketed here. Here, idea is like this. 14 by 41. I am doing 14 by 41. And one more thing, there is no ekachikono purbeno here in this method. This is called negative method. Here, since it is see, this is 21 and this is 20. So 21 by 21, I will erase this part. Say 1 by 21. I'm expressing in terms of 1 by 20 only. So therefore, there is no ekachikono purbeno here. I have to divide by 2 only. Okay, these are all 20 because n is suppose n is equal to 2. So for 1 by 21, I have to divide by 2 only. For 1 by 41, I have to divide by 4 only. There is no ekachikono purbeno here. The same digit. So basically, now what I do 14 by 41, I am dividing 14 I will divide by 4 only. So what did my quotient and remainder?
3, 2, 2,
3 and 2.
3 and 2. Yeah.
So now, in case of 14 by, I just compare it. Suppose I wanted to do 14 by 39. So here also you would have gotten ekachikono purbeno you have to do here because it is ending in 9. So 14 by 4 you have to do. So here also you get the 3 and 2. 3 as quotient and 2 as remainder. 14 divided by 4, 3 and quotient, 3 as quotient. And now the next should have been 23. And with 23 divided by 4, again 5 and 23, so 5 and 3, like this, isn't it? But here I did something like that. I consider that as if the 3 has a vinculum here. So 22 and vinculum 3 have becomes how much? We do not write the vinculum because I don't want to spoil this line. So the 2 and this I write in bracket. So this is as if it is 17. You understand the idea here? Because there is minus here, you see? Because there is minus. This minus. Everywhere there is minus. In each step, I have to do this minus thing. You just understand this. Now, next operation, I do it 17. So 17, 17 if I divide by 4, becomes how much? 4 quotient and 1 remainder. It becomes 14. In case of like, had I got 14 here, in case of 39, I would have done directly with 14. But here I have to do what? This, as if I consider that, but mentally I will do not write it because it will spoil here. So it is actually 1 and vinculum 4, that means or 1 into 10 minus 4, which is 6. 6 I divide by 4. 1 is quotient and 2 is remainder. Again, 20 minus 1. 20 minus 1 is 10 minus 4. 20 minus 3 is 17. 10 minus 4 is 6. 20 minus 1 is 19. 19 I divide by 4. 4 quotient and 3 remainder. 30 minus 4 is 26. 6 quotient and 2 remainder. 20 minus 6 is 14. I come back to 14. Therefore, I'll come back. This has 5 length. 41
Sir,
divided
I have,
by 5 length.
yes, sir. I have one doubt, sir, like how we got 17. Like when you do 14 divided by 4, you get 14, 4, 3 or 12, 2 reminder. And how do we get 17, sir?
20
Like again,
minus
we
20 minus 3. I got 7.
okay.
We consider that while finding out the next what to divide, next step
Number.
step dividend, I have to do as if I have to consider this. There is a vinculum here. Okay. Finally, I do not write that vinculum, but I have to mentally have to consider that. So, or we can say that it is 20 minus. Earlier we did 20 plus 3, isn't it?
Yeah.
Earlier case we did 20 plus 3 and 10 plus 4 and so on. Here we do opposite, minus 3, because of the minus symbol. So 20 minus 3, sorry, 20 minus 3, 10 minus 4, 20 minus 1, 30 minus 4, 20 minus 6, and so on. So therefore, I get this 1.34146.
Sir, in the second case, you said like 17 we get by 20 minus 3. Okay, because we have curriculum. Then how about 6? In the next case, 1 like yeah 6.
No, you got it 14. No, 14 you got. So 1 and 4 vinculum is actually 6. 06.
Okay, so 14 like you mean to say like we will subtract 10 again 16. Okay, 16 minus 10 it will be 6. Okay, try sir. I'll try and let me.
You please try. You say, let us try this one. Say, please try 19 divided by 40. So I do, say I do 19 by 41. Okay.
Okay.
Tell me what to do. So 19 I should divide by how much?
4. 4, no?
4, not 5, 4.
4.
So 19 divided by 4.
4 I'll get and remainder will be 3.
4 I get here.
Yes.
Remainder I get 3, isn't it?
Yes.
Now, what would be the in the bracket? I write the
Curriculum.
26.
26. 30 minus 4 is 26. Now 26 divided by 4.
No, 6 2. 6 2.
6 2 sir. 6 and remainder by 2.
Yes.
Twenty-six. 26. This is again 16. 16.
20 by 4.
16.
Yeah, others also can say, participate and understand.
14 in brackets.
14 exactly. 14 in bracket.
Sir, I have one question, sir. Like I was not able to understand like how 14 and 26 and 14 came. Like quite in doubt. You were saying
20 vinculum 6. 26
writing
and
here.
here vinculum 6.
Minus 4.
14.
Now the next step. 14. 14 divided by 4 is how much?
3 2.
3 2.
3 2.
Remainder.
Then it should be
17.
17. 17 divided by
20
4.
minus 3 is 17. Now,
Now 1 4.
1 4. 4 1.
4 1.
4 1.
Remainder
In bracket 6.
It's 6.
6. 1
1 and
2
Two.
4.
2.
1 2. Okay.
19. That's all.
19.
It
9.
just repeats after that.
So 20
Nine.
minus 1 is 19.
9
Oh, come back to 19. So therefore, what
4
is it? 4 6 3 4 1. Result becomes
4 3. 4 remainder 3.
4. You already here? This one? See? We started with 19, no?
Oh,
So it will again repeat. So therefore, 4 6
3
3
4 1.
3 4 1 is my result. It has only 5. So actually, 41. This has 8 cycles of 5 length each. 5 length. 8 into 5. So it has actually, because 41 is a factor of 999. I'll tell about that length of a recurring list. So this procedure is clear. Now challenge comes when I was here. So the challenge comes when something gets negative. I'll tell you how it comes. So I start with 1 by 21, which I skipped. So we proceed as follows. 1 divided by 2 is 0 quotient and 1 remainder. Now we have to do 10R minus Q. So instead of 10R plus Q earlier. So do 10 into 1 minus 0. So it becomes 10. You do not notice anything. Again, 10 divided by 2. So 5 becomes quotient and 0 becomes remainder. Now problem comes. The quotient is 5 and 0 is remainder. So therefore 10 into 10, 0 into 10 minus 5. So it becomes minus 5. How to handle this minus? So minus 5 when you divide it by 2, how much is my quotient and remainder? That is very challenging. So normally we think that 5 if we divide by 2, it becomes 2 becomes quotient and 1 becomes remainder. It must be something of that sort, minus 2 or something like that. No, it is the minus 3 is my quotient and 1 is remainder. Remainder is always positive. You always remember this thing, that remainder is always positive. Quotient can be negative, but not remainder. Remainder is always positive. Why maybe that I can clarify. Remainder is always positive. So basically, I elaborated it here. I don't have to always write it. It's already there. Minus 3 into 2 plus 1 is minus 5. This star I have note I have done. Then so far the result becomes 0, 5 and 3, because the 3 becomes my quotient. So again 10 into 1 minus 3. So 13. 13 divided by 2 is quotient is 6, remainder 1. So 0, 5, 3, 6. Now the next is 10 minus, now it is actually 10 minus 6 again, that way bracket, that 4 divided by 2 is, quotient is 2, remainder is 0. So that way it comes.
Gautamji, if you can put that line number showing 0, 1, 2, 3 and minus 1, minus 2, minus 3, I think they'll have this clarity on taking the next number minus 5 to minus 6. Earlier you have shown line number.
Like that in case of 14 by 41, here I am doing, see here.
Right.
Calculation of 1 by 21 can be represented as 10R minus Q format as follows. So I started with 1 divided by 2, isn't it? 21, I told you that 2 itself. So 1 by 21 will be 1 divided by 2, but in the negative format. So 0 becomes my quotient, 1 becomes my remainder. earlier with 10. Again 10 as if it is like same as the 19. Again 10 divided by 2 becomes 5 quotient and 0 remainder. Here, had I done it with 5, I would have gotten again 2 and so on. It is like 1 by 19 it would have been. But here actually it becomes a, see, vinculums are not coming properly. This 0, 5, 10 into 0 into 10 minus 5, it becomes minus 5.
Minus 5.
Minus 5. So when you divide minus 5 by 2, minus 3 becomes my quotient and 1 becomes remainder. This is minus 3 actually. Vinculum. Vinculum is not coming properly as I told. So I am doing it again. You see that vinculum, but it's not, it's overlap. So now 10 into 10, 1 into 10 minus of minus 3. That means it becomes plus 3. So it becomes 13 in the way. You understand? Had it
But
been,
in the previous,
had it
but
been
in the
3 and 1,
previous, in the previous step, we have not wrote minus 5, no, sir, because 10 into 0 minus 5, it will be minus 5, na?
if outside it is positive, inside it will be negative. If outside it is negative, effect will be inside it will be positive. So it becomes vinculums of vinculum means it becomes positive. So 1 and 3, that's 13. 13 divided by 2 is 6 quotient 1 remainder, and 10 minus 6 is 4. So 4 becomes 4. 4 divided by 2 is 2. 2 and 0. And again, 2, now 0 is there, so this again becomes minus 2 here in the bracket. Result is minus 1 and 0. And as a result, it becomes plus 1 again. So it comes back to 1. So you have to understand these things. Especially this one. This you must understand. Here it is minus and not be problem that minus 2 are dividing by 0 is minus 1, it will be. So it is understood. But here you understand that minus 5. Minus 5 when divided by 2 becomes 3 minus 3 quotient and 1 remainder. This is important. I compared the positive and negative methods. Compare the Excel sheet snapshots of positive and negative Vedic online method by 1 by 21. So had I done this one, 1 by 21 is 9 by 189. So 9 by 189 would have gotten like this. You would have got the result, but it would be very big calculations. First you do 9 by 19. So this one is, so 9 by 19 is 0 quotient and 9 remainder. Okay, 90. 90 divided by 19. 19 into 4 is 76 and 14 is remainder. 4 quotient and 14 remainder. 144. See, big numbers are coming. 144. Then 7 into 19 is 133 and 11 becomes my remainder. 117. So again 114 into 6 into 19 is 114 and 3 is remainder. So that way it goes. Whereas in case of this one, it is, although it is concept wise, it is little out because it is new concept, so you have to do little practice. So 1 divided by 2, 0 and 1, and again 10, it becomes 10 divided by 2 is 5 and 0, and because 0, 5 becomes actually 0 minus 5. As a result, it is 3 minus 3 is a quotient and 1 is remainder. It becomes positive here. 13. 13 divided by 2 is 6 quotient 1 remainder, and 10 minus 6 is 4. 4 divided by 2 is 2. 2 and 2 here. 2 becomes negative, so it becomes minus 1 and 0. So now when we this one actually, it becomes, result becomes this 5 and this 3 becomes 47. And so this part, this is basically vinculum. So 5 and vinculum 3 becomes 47. This is same as this one. And 2 and vinculum 1 become 19. So you get the same result basically. Obviously, should be. So, but with some vinculums, wherever you got the vinculum on your this one, it has to be taken into to account and becomes, you have to release the vinculum. So that is the idea. 13, so 1 by 13 here. No, it's 14 by 30, sorry, 14 by, not 30, 31. 14 by 31. 14 by 31 is how much? This one. You get here also, this 3, 1 is 29. This is actually becomes 29. And 6 minus 2 becomes 58. I repeat. Here we get 3 and vinculum 1 and 6 and vinculum 2. So we get 29 and 58. So that is the idea. 35 by 51. Here also we get recurrent length is 16. Here recurrent length was 15. So here also we get these numbers negative here and here. Most of the time we'll get positive, but sometimes you will get negative. So now basic online method A7, you can choose. Here actually denominators ending in 7 can have two different ways. But both will be comparable actually. But actually slightly one is slightly less. You can choose. But denominator ending in 1, obviously you have to multiply by 9 both the sides. That you have to do with a negative number only. If you multiply by 9, it will be very big. But here in case of 7, you can do two ways. Either you can denominator and numerator both you can multiply by 7, or you can both you can multiply by 3 to get in ending in 1. In case you multiply by 7, it will be ending in 9. So like this, I give the example, say 8 by 17. It can be expressed as either 56 by 119 or 24 by 51. The positive method, you start dividing 56 by 12, you get like this. Here are the snapshots from Excel. As I told you, the formula you can do. So you directly get these numbers. Or negative method you can do. And then we start dividing 14 by 5, but in negative, so that you get here, you get two negatives here. So later on, you can make them release. So you try these things. It will not be, if the Excel, this particular slides are there, so you can try these things with those brackets and so on. You can do, and it will be all right. So there are exercises on recurring decimal as like this. Now the periodicity, how the periodicity comes? Periodicity of the recurring decimal are that they are actually depends upon their denominator being a factor of repeat 9. Denominator being a factor of repeat 9. Repeat 9 is called all 9 repeated any number of times, 9, 99, 999 and so on. So denominator 3 has periodicity 1, 3 or 9 because it is a factor of 9. The 9 itself is of course same. The number 3 also factor is the 799, but 9 is the minimum of all. Minimum you have to consider. Earlier you show that we tried 11, so divided by 11, it becomes a factor of 99, so it has periodicity 2. Similarly, there are, if it is denominator is 27 or 37, periodicity has 3 because it has factor of the factors of 999, 999. 41 we have already evaluated. It is periodicity 5 because the 31 is a factor of 999, 5 numbers of 9. These all 7, 13, 21, 29, 63, all the periodicities are 6. Some of them are prime numbers and some of them are composite numbers also. They are composite. That being factors of 6 numbers of 9. So I have a table actually like this. If we factorize, you will get like this. So periodicity 1 comes with 3 basically 3 and 9 we can say, 3 and 9 also, because the composite number 9 itself is 11, 33, something by 33 also will have something in 99, you get all the periodicity, periodicity 2. This 37, 27, these are periodicity 3. This is the only number, only prime number having periodicity 4. These are the prime numbers having periodicity. This is not prime, this is 41 into 3. So periodicity 5. These are the periodicity 6 and periodicity 7, periodicity 8 that we have. See, periodicity 19, 18 periodicity. See, 19 is here. So we have seen that 19 has periodicity 18 we have seen, because 19 is a factor of 18, 19 is a factor of 18 numbers of 9. If you write 9 18 times, 19 is a factor of that. So it is actually, so these all have periodicity. 57 is 19 into 19 into 3. This also, but this is independent. This is also prime number, 52579. This way it goes actually. I've given a big table, but only one part of it is displayed. Now, R stands for repeat 9 number. And H stands for H stands for hollow numbers. Hollow is actually something is both side 1 is there, and in between 0. This is named as hollow. So while factorization, I find this one. Very quite details. You may not always. Those of you are interested, you can read this part. So therefore, dominant reason why it comes like that, because 41 is a factor of repeat 9 directly, whereas this one in case of C 101. Basically, 101 itself is a repeat 2. So this is actually it is actually a factor of 9999. Basically, this 99 into 101 is 9999. So obviously, this becomes itself is this one. So that way, actually, the dominant reason why it is becomes behaving that way is actually basically consideration. If somebody interested in mathematics of this kind can do. So any question here? Some more practice is required. Suppose let us try this one. Should we try? (23 by 51). What should I do? How much is should be divided by how much?
5.
23 by 5.
5.
Four and 3.
4 and
3.
3.
26.
Then
5 and 1. 5. Zero and 5. Sorry, 1 and 0. -1. That is
Vinculam.
-1.
Very challenging. Anybody can get confused.
Then this one will be
Something you have to find out.
1 and -9.
-1 is equal to x into 5. Okay. Plus something.
6. 1 and 6. Sorry. -1 and 4.
Exactly. -1 into 5 plus is plus 4. Therefore, how much it becomes? -1,
-1.
-1 and 4. Now here bracket how much? Here you write vinculum. Very important. Because that vinculum will finally, it will be, you have to release. Here actually on the result line you are writing vinculum. So it becomes how much?
8 and 1. 8 times 5 is 40
80.
and
Because no, in bracket you write how much? You write 41, isn't it?
yeah,
39. 41.
41. Had it been +1, would have been 39, but here it is 41. Now 41 when we divide by 5, how much?
8 and
8.
1.
81.
8. And now the next step is
18.
81. 81
No. 10 minus 8 is 2.
10 minus 8 is 2. Now you just match with the calculator because it is length of actually this length is something like 16 or so. So you just so far whatever you have done, you have not committed any mistake, then it will automatically 23 by 51. So you not always have to come back to the recurring end. You have to only you can see only see that this also only see that how much is coming. So our result was like this. How much is the result? Can anybody say? Point
4, 5, 1, 1,
4,
8,
5, 1.
1, 8.
4, 5, 1, vinculum 1. 8. Okay. So is equal to 0.451 vinculum is how much? 1 vinculum 1 is 0.9, isn't it?
09. Yeah. 45098.
08.
So in each case you do only few digits, 5 digits, 6 digits like this. Then you can see. You got the idea, now? Basic idea is that. Especially this one. Next step also you can do. Next step another this 0, 2 it comes. 0 and 2. So again that will be.
Excuse me, sir. It is 0.450. You have written 9 for vinculum 1.
1 and vinculum 1, this part actually. 1 and vinculum 1 become 0.9. You have to maintain that number of digits. You cannot write 9. You have to write 0.9. 1 and vinculum 1 becomes 0.9.
0. Oh, okay, sir. Thank you.
Here next step also is on that challenge is there, 0, 2. So again it comes to 0, 2 divided by 5 is my 0 becomes my quotient and 2 becomes my remainder. Okay, 0, 2. So 0 quotient, 2 remainder. Here it is fine, but again 0 and 2. So
20.
it becomes
5 to the 10.
20. Because 20 minus 0 is 20 itself. But now it comes actually to 4 and 0.
No, in the bracket, shouldn't it be 10 instead of 20?
Why?
Because 5 times 2 minus 0.
No. 2 I was dividing by 5. Isn't it? I was dividing this 2 by 5. So 0 becomes quotient and 2 becomes remainder.
Right. But then the bracket number should be 10.
Bracket is 2 into 10 minus
10
0. 2 into
Okay,
10
sorry.
minus 0, not plus 0, but minus 0.
Okay,
Minus 0 and plus 0 are the same, so it is 20.
Yeah,
But
got
now it comes actually 4 quotient and 0 remainder. Here it becomes challenging. It becomes minus 4. Minus 4 will be how much? Minus 4 divided by
10 minus 6.
it is actually minus 4 divided by 5. 4. Minus 4 is equal to how much?
Minus 10 and 6.
Plus
Minus
6.
4
Minus
is equal
2 and
to,
6. Minus 2 and 6.
minus 4 is equal to 1 into minus 1 into 5 plus 1, isn't it?
Oh, yeah.
Minus 4.
So it is minus 1 is my quotient and 1 is remainder. So 1 minus 1 it becomes 11. So here also you'll find that in the result that there is somewhere like this 11 also now you get 11, 5, 2 and 1. So therefore the next digits will be after this 098 there will be how much we got? 0, na? After 8 you got 0, 0, 4, you got this 0. So after that we got 0, 4 and minus 4 and vinculum 1. 0, 4 and
is this called the maximal length sequence?
what?
No, is this sequence called maximum length sequence or you
No,
said
no,
something?
no, actually it is
Because this process is very similar. Actually, it's almost the same when it is used with binary numbers, and computers use it to generate pseudo-random binary numbers, actually, which is like the basis of all
nothing
ATMs.
like that. It is only this division by particular number. It is binomial expansion with negative. So this is got slightly cumbersome. Result is correct. So my result we got like this 0.45 45 1 vinculum 1 8. Then we got this 0 4 and vinculum 1. That leads to is equal to 0.45 09. 1 and vinculum will become 09. 8 0 and 4 and vinculum 1 becomes 39. So calculator shows this correctly. Yes. After that again 2. Only normally there will be in the cycle there will be only 2 such negative things. Here we got both the 2. In 23 divided by 51, it got like this. There are two cases of vinculum 1, vinculums. Okay. Whenever you remainder is getting 0, when something is matching, say dividing by 5, if it is multiplied by 5, so remainder will get 0. Here that negative challenge comes. Otherwise, it is always positive, and most of the time it is positive. So I hope it is understood now to some extent. You just practice it. So we started. You practice all these things. There are mostly they end in 9. Some of them you have to multiply, as you know, it is multiplied by 3 and so on. So
Can you put a PDF for this note, sir?
which one?
These notes.
We have already circulated the PPT file, no?
I didn't get it. Okay, I will.
Oh, you please see the group. It is already one day earlier. It is already circulated.
Okay.
You please go through this. All these slides are there. I
Thank you,
didn't change. I didn't change anything. Later I'll change some problems. I may modify, but not. So if you try this one, 39 you will get 39 you will get 6 length. You can be there. With 49 you get length as 21. Sorry, 42. Excepting when it is divisible by 7. Here you get only 6 length. So 6 plus 42 becomes 49. 49. That is what remains. So today I didn't start. Please ask more questions. We get actually because I don't want to start today this one. So let me complete. Any question from the previous one? Any slides? So if some time is remaining, I can also show this one.
So this is like a geometric series.
Huh?
This is a geometric series. 1 divided by 1 minus x is 1 plus x square plus x cube.
The binomial series. Binomial.
It's
I think
binomial is fixed
Padmavati
length.
garu has a question.
Huh.
Padmavati garu adagandi.
Namaste, sir.
Namaste.
Regarding recurring decimals, please explain that point one more time, sir.
Regarding this, please tell me.
Recurring decimals.
Yes.
Periodically, the length of the recurring part in decimals.
మీ క్వశ్చన్ కాస్త ఎలాబరేట్ గా చెప్పండి.
ఇది ఎలా చేయాలో ఒకసారి గురుగారిని అడుగుతున్నానండి. మళ్ళీ ఒకసారి
కరెక్టే, ఎక్కడ అన్నది తెలియట్లేదు. ఎక్కడ మీకు డౌట్ వచ్చింది అన్నది తెలియట్లేదు.
గురుగారు ఇచ్చిన నోట్స్ లో డినామినేటర్ D=3 అని ఇచ్చారండి. అది నాకు అర్థం కాలేదన్నమాట. Minimum of 999.
Oh, that you are telling about the recurring length. Recurring lengths.
Yes. Guruvarya.
Anything actually is the recurring length becomes, if the denominator becomes a factor of how many minimum numbers of nines. Minimum numbers of nines. Okay. So that becomes the recurring length. Suppose 11 is a factor of 99. So 11 has recurring length as only 2. So 37. 37 into 3 is 111. Obviously 37 into 27 is 999. 37 into 27 is 999. So both 37 and 27 will have recurring length 3 because they are factors of 999. Okay. That is the idea. So here is the Excel sheet. Those of you are interested can see like this. What I did. All these things I found I went up to say denominator up to 99, then 119. I did a lot of say 209, 239, 289, 309, 339. Okay. This is the closest of pi, say 3.1415929. The 26536 is actual number. So this we get here. So this all these things. This is 113. So 113, you have to do something by 113, you have to do like this. Something by 339. So this will get. So this all these things. Sometimes remainders becomes 2-digit numbers. So this is the Excel sheet, and how to do it. Here you see. Here integer int function. How many people are do you understand Excel sheet and Excel functions? Some of them must be there, no? So the 10 into this plus this divided by, basically I'm doing dividing this 10 times the remainder plus the previous one divided by this thing integer part of it. And then this one I'm doing the mod of that. Mod means remainder actually. So that way, and I'm formula I'm just putting like this and then dragging right side. So that way you got negative. Here also negative things are there. See here 41. Earlier we got 14 by 41, no? 6 by 41. See, this is 14341. 34146. Earlier we got 14 by 41. So it is 1434634. 6 by 41. Just now I got 23 by 51. You remember the 23 by 51 you got? Suppose I write 21 here. 23. I write 23 here. So remember you got the figures, no? 4, 5, 1, minus 1, 8, 0, 6, 4, minus 1. You got like that? Remember? We evaluated? This is coming here.
Yeah.
That's why this formula it is evaluating. Okay.
Is it only the formulas we have used in the or we did any coding, VBA coding?
Huh?
In the Excel. In the Excel, you did any VBA coding? Visual Basic coding, or it's only formulas you have used?
Formula, only formula. See, this is first time it is coming positive. See, but next time onwards it will be negative. See, this is negative.
Okay.
So that is the idea. In case of this positive, negative. Then I did also hexadecimal numbers. Hexadecimal numbers.
Okay, sir, can you share, yesterday you was mentioning that you are going to share us with an PDF of for practice, like this concept. There are, because we could not get books till now, like maybe tomorrow again we'll have an way.
Oh, that one. Yes. I will do it.
Okay, thank you.
See, hexadecimal number, those of you who understand hexadecimal number will be say 0, A and A is 4, all these things. Actually, from these numbers, I just converted it into a hexadecimal number with a remainder in the left. You get it that.
Okay, Gautam ji, I think now we'll have to break for Pradhana.
Okay.
And then come back.
Okay.
Babu garu.
Okay, thank you.
ధన్యవాదాలు గురుగారు.
Thank you so much.
Thank you.
Thank you for removing the sharing. Now we will proceed with Pradhana.
Sudhir Pattarji is there if he wants to do the Pradhana.
Okay, Sudhir ji, namaskar.
Namaskar.
I request you to please say chant Swasti Mantram, please.
Om Swasti Prajabhyah Paripalayantam न्यायेन मार्गेण महिं महिषाः को ब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतम् सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः ॐ सर्वे जनाः सुखिनो भवन्तु स्वस्ति
స్వస్తి. హరి ఓం. గురుభ్యో నమః. ధన్యవాదములండి సుధీర్ గారు. థ్యాంక్ యూ సో మచ్. Now let us request Chala Chitibabu garu to recite national anthem. All of you please rise.
गण गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद जय हिंद.
ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Now we will go for any other questions if somebody has. Anybody wants to ask any questions?
So when we use this formula, at that time the value should be less than like the modulus should be less than 1. Like 1 by x is there, the denominator should be less than 1. When we say 1 upon 1 minus x, that x is less than 1. For hexadecimal, so it is less than 1 over 16 then in that case, right?
No, hexadecimal less than 1. Binomial
Because
expansion.
the series will converge if the value is less than the right hand side,
Less
which
than
is
1.
oh less than 1. Okay.
I was octa, sir. 8, no?
Which one?
Octa, like hexa we have 16, octa will have 8. Binary.
You can also do like that. You have to do appropriately that what actually you are doing it.
Okay.
Like here, what do you do? 10 times the remainder plus quotient. Okay, in case of positive and minus quotient in case of positive. If you do 8 times of the remainder, and always in the hexa in X format, what is the remainder and so on. So then it will be. I'll tell you. I'll show you that particular.
No, but we do 1 over 10n because it's a base 10 system. But if the system is hexadecimal, it's not 1 over 10n, it's 1 over 16n at that time.
1 over 16m, yes, exactly. So therefore,
then,
you have to do 16, you have to do accordingly.
Okay, so therefore the number should be less than 1 over 16. It should be 1 or less than 1 over 16 for the series to converge actually, right?
No, it will automatically 1 by 16n also will be less than 1, no?
Right.
It is a binomial expansion to be valid. It should be less than 1. So 1 by 16n, in any case, 1 by less than 1.
Yeah, you're right. Yes, thank you.
So like I have a doubt which is different from all the concepts what we learned. Like there can be a suffix for a number like 2 and n. Like n has a suffix, prefix of 2.
N has a prefix of
2. Like we have a power when you write n power 2, no? In the same way, 2 is coming with the prefix downside. Is it possible? It is something different. I'll just message you on the WhatsApp. That's better. Not to interrupt the class. Yeah.
the suffix and this is there is particular characters are there.
Okay.
You want to mean to say that way of writing, how to write it.
Writing not. It's a different concept. I'll discuss in your WhatsApp because it's not related to this.
Right.
Thank you, sir.
I think if you have any questions on this particular whatever has been taught now or in the previous classes, I think that is better.
So I will open
Yeah.
that one instead of sharing this one. I'll open share
Right.
share that.
But in case people have doubts, if they don't have any doubts, then we can as well close
because
the class.
next week is the last class.
Yeah.
So better actually that if, people I will just revise from the very beginning.
Yeah. Babu Garu, I think
Okay.
if
Now-
you can tell about the next practice test.
Okay, let us talk for about few minutes on the practice test. The test will be on. Can I close this
Sharing.
presentation, sharing?
Oh yeah.
Okay. Thank you. Thank you, Goutamji. One important thing is that this Vedic mathematics needs little practice. All of you, and this is the most interactive session we have for all the classes. Generally, all classes, for 1 hour we teach and another half an hour question answers. But this is the one right from, minute 0, you are all open only. Nobody is muted. So you all have to interact, and mathematics, as we are discussing, is, if you see, you will not get. If you hear, you will not get. If you read also, you will not get. You have to do. That is, the simple things, unless you have to do, you will not. So this practice, this Vedic mathematics is not part of the exam. For the practice test only, which is going to be on 9th. 9th, no? I think it is on 9th.
7th, isn't it?
9th.
Okay.
Practice test is on Wednesday.
One more class is there actually. One more class is there on my.
One more class is on 8th. So they need some practice before they face the exam. So it will be for the next practice test, which will be 1 month later, 1 or 2 months later. Maybe that will be in December. But before that, any doubts?
It can be on the say next week of that. Say 15th or 16th, something like that. No.
Of October. Yeah, this we can have one practice test for Vedic mathematics only.
On Saturday.
Because it will not be so far that they will forget also.
Yeah. Yeah. But it can be only on Saturday because we have other lectures lined up.
So Saturday following, because there is this 6 days gap is there. So there is a